Welcome to the next session, my dear friends. In the previous session, we were discussing about how to find the chlorine residual present inside the water. So we have discussed the orthotoluidine test, orthotoluidine arsenate test, and this starch iodide test. So in this session, we are discussing the rest of the methods by which we can find the chlorine residual. In that, the next test is chloro test. So okay, we use chlorotex in this test. So chlorotex test. So we use chlorotex here. So it is a color matching technique. So here we perform this test using color matching technique. We perform this test by color matching technique. Okay, so the reagent which we use here is BDH chlorotex. Reagent is British Drug House chlorotex. So how we do this test is 50 ml of water we take, water sample, and we add 5 ml of this BDH chlorotex. We add 5 ml of BDH chlorotex. So now it forms a colored solution. Okay, it forms a colored solution. Excuse me. It forms a colored solution, and we check the concentration of the color. The concentration of the color indicates the concentration of the residual chlorine. Okay. So generally pink color is formed. Okay, it forms a colored solution which is pink. So the concentration of color indicates the concentration of Cl2 residual. Indicates the concentration of Cl2 residual. Okay. Indicates the concentration of Cl2 residual. This is chlorotex test. And next is DPD test. Diethyl paraphenylene diamine test. Okay. Next test is DPD test. Next test is DPD. This is chlorotex test. Next is DPD test. Diethyl paraphenylene diamine. So this is DPD test. So in this test, it is also a color matching technique. Okay. So here the reagent is DPD. Okay. It is also a color matching technique. It is also a color matching technique only. But the reagent is DPD. Reagent is DPD. That is the only difference. So whatever the color formed, just check the color concentration. That will give you the Cl2 residual concentration. Okay. So these are all the tests which we perform to determine the Cl2 residual, and the last concept which we are going to discuss is factors affecting chlorination. Factors that affects the chlorination. Factors that affects the chlorination. So first one is turbidity. So what is the effect of turbidity on chlorination? See, when the turbidity is more, then the microorganisms can go and hide behind the turbidity. For example, if some war is happening, if some war is going on, if you find some hiding places for you, then you can easily escape from the bullets, right? Similarly, in the same manner, so here our bullet is chlorine. So if the water is having more turbidity, then what happens? The bacteria or microorganisms can hide behind these kind of turbid particles so that it cannot escape from this chlorine, directly attack of chlorine. Okay, so that is why to attack the remote locations also, then we need more amount of surface area of the chlorine needed. That means more dosage is required to cover the surface area of the turbidity. Okay, so in order to reach the hiding locations, it has to cover all the surface area of the turbidity, and then it can find that bacteria or microorganism. That is why generally turbidity is more, then the dosage will be more, and if for the same dosage if you are doing, then the efficiency will be less. Okay, efficiency will be less. So efficiency will be more when the water is having less turbidity. When the turbidity is more, then the chlorine efficiency will decreases. Okay. And the second property, that is metallic compounds. See, metallic compounds, if more, then what happens? These metallic compounds also need chlorine. So because of which the chlorine is not sufficient for doing a disinfecting process. So actually metallic compounds can be removed in any manner, but if it is removed by chlorine, then what is happening here? So here the chlorine is not sufficient for the disinfection. Okay, that is why, so when metallic compounds more, then the efficiency of the chlorine will be reducing for disinfection. And the third one is pH. So when you take pH, so pH in acidic medium, and the pH is lesser, then the HOCl, more HOCl will be present. So HOCl is better disinfectant. That means when pH reduces, the efficiency of the chlorination increases. When pH is in between 5 to 7, so reduces means if it reduces less than 5, then chlorine may not react with water. Okay, that is where pH should be less. That means it should be in between 5 to 7, then the efficiency will be higher. Okay, efficiency will be higher. And next one is time of contact. So more time if you keep in contact with the chlorine, more will be the effect of efficiency of the disinfection. So more contact time if you provide, then the disinfection efficiency will increases. Disinfection efficiency increases because you are providing more time in the chlorinator, so you are having more contact with the chlorine. So that means more disinfection is possible when you are having more contact time. And next is temperature. So when temperature is more, so due to temperature also some amount of microorganisms will die. So the chlorine, so temperature will help the chlorine in doing disinfection. That is why, so chlorine efficiency increases because temperature also helps to kill the microorganisms. So these are the different factors that affects the chlorination. So this is all about the chlorination. Now we are moving on to the last topic of treatment of water. The last topic of treatment of water, that is miscellaneous treatments. Miscellaneous water treatments. So miscellaneous water treatments is nothing but, so I told you already, so whatever the treatments we have discussed so far, these are all conventional that are present for all the kinds of water. But some waters may have different problems, so those needs to be treated separately. So those are called miscellaneous. Miscellaneous water so miscellaneous water treatments. So in this miscellaneous water treatments there will be many things, so let us discuss one by one. So first one is aeration. So what is meant by aeration? So generally sending air into the water. Okay, aeration means, so dissolved gases, it is associated with the dissolved gases. Okay, so either we will send the gas from the air into the water, or else we will release the gas from the water into the air. That is nothing but aeration. So exchange of gases, allowing the water to exchange the gases with the environment to establish saturation. Okay, so aeration is nothing but exchange of gases or dissolved gases from air to water and vice versa. Okay, so generally this aeration is very much required for groundwater sources. Surface water source, always it is having the exposure of the external environment. Okay, the surface water source, always it is having an exposure to the external environment. So this aeration takes place in surface waters, but whereas in groundwater does not have any environmental interaction, because of which groundwater predominantly needs aeration. Okay, so it is predominantly needed in groundwater. It is predominantly needed for groundwater. Okay, so now here, see, during this exchange of these gases, okay, and also sometimes the exchange of metallic ions, that means, so because of this aeration, okay, so, and this aeration also, it also neutralizes dissolved ions in free form. It also neutralizes dissolved ions in free form. For example, if you take the dissolved ion, like iron and manganese, if they are in their free form, okay, so iron and manganese converted into insoluble state of precipitate. So these are all in the form of dissolved ions. For example, Fe2 plus, okay, Fe2 plus, Mn2 plus. So these are in the dissolved form inside the water, but they are in free form. They are not in any kind of bond. Then these ions will react with the oxygen present inside in the air, they react with oxygen inside the air, then what happens here? So they will become FeO, it becomes FeO, okay, it becomes FeO, and this will become MnO2, okay, this will become MnO2, and this FeO again reacts with water, okay. So this FeO reacts with more air. If this FeO reacts with more oxygen, it forms Fe2O3, okay, Fe2O3, and this Fe2O3 further reacts with H2O and forms FeOH thrice, which is a settlable precipitate. This is nothing but floc. We call this as floc. So likewise, generally the iron will get removed, and this also manganese also gets removed in the same manner. So these things, so by aeration the dissolved iron is oxidized into ferric oxide, which is insoluble in water. Similarly, manganese compounds are also formed and becomes insoluble. So iron and manganese, earlier they are in soluble format. So after aeration they are becoming an insoluble format. Our intention here is, whatever be the dissolved impurity, if you can make it a insoluble precipitate, if we are making it an insoluble precipitate, then it is easy for us to remove that insoluble precipitate. So that is our agenda here. Whatever we do in miscellaneous water treatment, so all the impurities we will convert them into insoluble precipitates. These insoluble precipitates in turn are removed either in sedimentation or sedimentation aided with coagulation or in the process of filtration. So we will perform this miscellaneous treatment and convert the impurities into insoluble format, and those insoluble format will be removed in any of the systems which we have discussed so far, okay, which we have discussed so far. This is about aeration. And here due to the hesitation of water during aeration, so generally what we do, either we allow the aeration naturally, or sometimes we will provide aerators inside the water. So these aerators will rotate inside the water, okay. So during the rotation of the aerators, some amount of microorganisms can also be killed because of the movement of the aerators, okay. Some amount of disinfection can also be achieved during this hesitation process of aeration, okay. Hesitating means rotating with an aerators, okay, rotating the water with an aerator, so that to increase the surface area of the water, we do rotation with the aerators, okay. So the process of aeration is performed by exposing water into the atmosphere. So whatever the process of aeration we do, we want to just have the more interaction of the environment with the water. So to have a more interaction, we need to increase the surface area of the water. For example, if we take a mug of water, okay, so this is an amount of water, okay. Now this amount of water, if I am taking in a flat plate like this, the same amount, the amount of water here and the amount of water here is same, but here we are having more aeration, here we are having less aeration, because here we are having more surface area, here we are having less surface area. So aeration can be effective when we increase the surface area of the water. For performing this, for achieving this, what we do generally, we provide aerators which rotates the water. This rotated water will spill out, so because of which the surface area will increase. And there are also some other methods to increase the surface area, okay. So to increase the surface area, but the concept here is, whatever the interaction you provide, what happens is, see, two things we need to see in aeration. One is the concentration of the impurity, or the concentration of anything, any kind of dissolved gas, okay. What is the concentration of the dissolved gas inside the water? So generally there will be two concentrations. One is saturated concentration and another one is actual concentration. So what is the concentration present in the water, whether the actual concentration, whatever the concentration present inside the water, whether it is more than the saturation or less than the saturation. So the exchange of the gases, okay, absorption or desorption. We call it as desorption. Okay, so aeration, it happens in either way. It happens either by absorption or desorption, or by desorption. So the aeration can happen either by absorption or desorption. So when absorption happens, when desorption happens, when absorption happens, when desorption happens. See, when the actual concentration of the gas, okay, an actual concentration of the gas, if the actual concentration of the gas inside the water, if it is less than the saturation, then absorption of the gas will take place. Absorption of gas takes place. So for example, O2 concentration, actually it is less than O2 concentration of saturation, right? So whatever the O2 concentration present inside the water, O2 concentration in water is less than the saturated concentration in water, right? It is less than the saturated concentration in water. Then in this case what happens? O2 is absorbed from the atmosphere. O2 is absorbed from atmosphere. If H2S gas is, for example, H2S gas actual concentration is very high than the H2S saturation, then in this case what happens? So H2S is released, dissolved from water into atmosphere. So absorption and desorption, if you understand, if the actual concentration in the water, if it is less than the saturated concentration, then O2 will be absorbed from the atmosphere, okay, or any kind of gas. If the gas actual concentration is more than the saturation, then the water will release out that impurity or that gas into the atmosphere. This is how the aeration happens. The rate of absorption or desorption, so the rate of absorption or desorption depends upon the difference of Ca and Cs, okay. So we call the rate of absorption or rate of desorption, it depends on the difference between the Cs and Ca. Rate of absorption and desorption, it is classified as, it is taken as dC by dt, which is proportional to Cs minus Ca or Ca minus Cs, whichever is greater, okay, or Cs minus Ca, Ca minus Cs, whichever is greater. Cs is saturated concentration, and Ca is actual concentration, So when Cs is greater than Ca, absorption takes place, and Cs is less than Ca, desorption takes place. Okay, desorption takes place. Now, what are the different techniques we use for having more dispersion of water into the air? I told you here we need to increase the surface area of the water. We need to increase the surface area of the water. This surface area can be increased by many ways. So there are many methods by which you can increase the surface area of the water. Let us see what are the methods we are having. techniques of various techniques of dispersion of water into the air for aeration. Dispersion of water into the air. Okay. To disperse water into air. First one is water fountains. First one is fountains. So fountain means you will be having a fountain like this. So from here you will spray the water into the environment like this. You will spray the water into the environment like this. So this is a continuous process we do. So this is nothing but water fountains are simply fountains. So it is a spray aerator. Okay, it is a spray aerator. It is a spray aerator. And in this aerator, 70 to 90% CO2 and 99% H2S is removed. 70 to 90% CO2 and 99% H2S can be removed. So 70 to 90% of CO2 and 99% of H2S is removed in this kind of fountains. And next one is cascading. So cascading means, so this kind of stepped aeration, we also call it as stepped aeration. So we form a stepped kind of thing. So we allow the water to fall through these steps. Okay, we allow the water to fall through these steps. 50 to 60% of CO2 is removed in this method. Okay, 50 to 60% of CO2 is removed in this method, and a type of 35% of H2S is removed. Here 35% of H2S is removed in this method. Okay, here third one is the tray tower. Tray tower, it is a kind of a shower. So if you are having a tray which is having holes like this, if you take water, so it will be falling. This the tray tower will allow the water to enter out of these holes. Okay, so in the form of a shower like this, and you will collect in the other tray. Okay, we will collect this water in the other tray, so by which we can increase the surface area of the water to have more interaction with the environment. Okay, so this is also a type of free fall type, also called, see, this is here in this tray tower aerator. So this is a kind of a free fall of water. We are allowing the water to fall freely, so that is we call it as a free fall tray tower also, sometimes free fall tray tower also. Okay, so here in tray tower, if we use a gravel bed, okay, here to have a kind of porous media, okay, so that the water will enter like a jet, like a shower. So that for that we can achieve that by using a gravel bed or anthracite or coke, whatever it may be. So we can use anything to achieve this kind of porous media. So in tray tower, the porous media can be formed by anthracite, coke, slag, etc. So any material we can use, so that it should be very fine, such that it will allow the water in the form of a just jet. Okay, so another thing which we use here is gravel bed also. Gravel bed also we use. So gravel bed, so mostly we use gravel bed. Most of the cases we use gravel bed only. In most of the cases we use the gravel bed. So this is one of the most efficient method for the removal of CO2. So this is the tray tower is the most efficient method for removing CO2, but not other gases. Most efficient method to remove CO2. Okay, to remove CO2. These are the methods which we see. The percentage removal of a CO2 and all are not needed, because it varies from tray tower to tray tower depending upon the type of bed we are using. So that is why we cannot have a firm values. So this much will be removed like that. So that is not needed for us. So these are the three kinds of techniques which we use to have desorption. Like here, whatever the absorption, desorption we are doing naturally, but another method we do is we send the air into the water. Okay, here we are not sending any air into the water, so it is naturally happening. If you are sending air into the water mechanically, so that is also a technique by which we can send the air into the water. Okay, so generally in skimming tanks we will discuss it in the sewage. So in skimming tank also we do the same thing. We will send air from the bottom, okay, in order to collect the oil and greases. In the same manner, if we are sending air into the water, so that is again another technique by infusing the water into the air into the water. Okay, so here this is a tank. So you will be having a arrangement. So you will be having an arrangement like this, through which you can send air into the water like this. Okay, so this is the inlet of the water. So through this inlet the water enters, but so this water may not have sufficient amount of oxygen or sufficient amount of any required gases. Then those gases will be sent into the water in the form of a compressed air. Okay, in the form of compressed air. So this is one method by which you can increase the required gases, not all the gases, whatever the gas. Majorly the important gas in water is oxygen. So we send oxygen into the water in this manner, so that it will get absorbed into the water. Okay, this is another method. So it's sending air into the water using dispersion technique. Okay, this is called dispersion technique. Okay, this is nothing but dispersion technique. And now here there are some understanding we need. So when we call it as absorption, when we call it as desorption, by looking at the graphs. So generally we indicate these absorption and desorptions in the form of small figures also. So how to understand those figures? Let us see. See, there will be figures like this. So there will be a figure like this. Air, CS is, whatever air, CS is greater than CA. This is water. So from air into the water. Okay, whatever happening is from air into the water, right? from air into the water. So if you see this kind of figure, so what it is indicating, Cs is greater than Ca. So in Ca, actual concentration in the air, okay, actual concentration in the air is less than the saturation constant, is less than the saturation constant. Then what is happening here? What is happening here? So whenever there is a actual concentration is less than the saturation constant, then absorption will happen, right? When actual concentration is less than saturation concentration, then absorption will happen, okay? Then absorption will happen. So the actual concentration of O2 in water, for example, in this case, if you take an example, the actual concentration of O2 in the water less than the saturation concentration of O2, okay, flows from air into the water, that means water is absorbing O2 from air, okay, water is absorbing O2 from air. If the same thing, if you want to represent water here and air from the outside, then we need to represent the same thing like this. If you are taking water here, Cs is greater than Ca, then if this is air, so this is also absorption. If this is air, so these two indicates absorption only. So this is also absorption, this is also absorption. When air is outside, from air into the water, this is absorption, okay, this is absorption. So for example, and this flow happens only when the saturation is more than is actual. Here the actual is lesser. In the water, the actual is lesser. Okay, in water, this relation is in water. So this in water, actual concentration of O2 is less than the saturation concentration. So in that case, what happens? So absorption takes place. In that case, absorption takes place. Okay, in that case, absorption takes place. And a small correction here. In air, generally, so we are taking the concentration in air. In air, the actual concentration is more than saturation. So if the actual concentration is more than saturation concentration, then air will release into water. Here this is the concentration of O2 in air. In air, O2 concentration is more than the saturation, that is why it is releasing into the water. Here if you are taking water, the actual concentration is less than, okay, so here the actual concentration is less than saturation concentration. Actual concentration is greater than, here the actual concentration is less than. So that is why it is taking it from the outside air. Am I clear to you? Here in air, the actual concentration is more than saturation, that is why air is releasing it into the water, right? If you take water, the actual concentration is less than saturation, that is why it is taking from the air. Both are called absorptions. If you take O2 as an example, then you will understand it is very easily. Okay, next is desorption. So desorption means when you take the desorption, so then what happens? Desorption means these arrow marks here it will. So desorption means actual concentration in air is actual concentration in the air if it is less than. So the actual concentration in the air will be less than saturation, because if you take H2S, whereas in water it will be more. In that case, what happens? From water to air it will come. Actual concentration in the air is less than saturation concentration, but in water it is there. Okay, in water it is there. So that is why here it is called desorption. Here it is called desorption. When Ca of water, when Ca here, if you take water, that means the actual concentration in the water, if it is more than saturated concentration, the actual concentration in water, if it is more than saturation concentration, here the actual concentration, if you take water, so the actual concentration, it is greater than saturated concentration, then the flowing will be outside into the air. This is called desorption. And one more thing here, this is called desorption. So one more thing I want to add here is, so whenever we show these concentrations, this concentration should be of water only. Okay, we don't show it of air. Always this concentration we will show for water only. If you are keeping air outside or water outside, we can have two figures with water inside and air outside, and air inside and water outside, but the concentration always we need to show about the water. So that is why here also it will be actual greater than saturation, and here also it will be actual greater than saturation only. But everywhere, whatever we use, water and air interchanging, but this concentration should be kept for the water only. Okay, we will keep this concentration of water only. Okay, are you getting my point? If you see that, if you see it like that, there will be two combinations. One is when Cs is less than A and Cs is greater than A. Only two combinations will come. Okay, absorption. So two combinations for absorption and desorption. So at absorption, air inside, water outside. Okay, this is one figure. And water inside, air outside. Right? Similarly, here also for desorption, there will be two figures. One is air inside, water outside, and another figure is water inside, air outside. Okay. So absorption, when absorption happens, when actual concentration is less than saturated concentration. This is a condition of water, not of air. Actual concentration is less than saturated. So actual concentration is less than saturated concentration. This is a condition of water. Okay, condition of water. Now here we are looking air. So absorption always takes place from air to water. Absorption always takes place from air to water. So air to water means what this? So from air to water, this is absorption. Air to water. This is absorption. Okay. Desorption, when it happens when Cs is greater than Ca. Okay, when Cs is greater than Ca, that is condition of water. This is also condition of water. So desorption always takes from air to water to air. Desorption takes place from water to air. So water to air, desorption takes place. So water to air. So when it is moving from water to air, that is desorption. When air to water, that is absorption. No need of seeing these concentrations and all. By looking at the arrow mark movement, air to water, absorption. Water to air, that is desorption. Very simple to understand. Okay. So this is all about the aeration. So in the next session, we are going to discuss about activated carbon treatment, how to control algal growth, how to do fluorination, defluorination, hardness removal, desalination. All these things we will discuss in the next session. Thank you so much.